Hello guys, in this video I'll solve several questions as regards to integration. Okay, I'll make sure I solve questions across several aspects of integration. So I will advise you don't skip around this video. As I solve the problems, I will explain the concepts behind each of the solutions. So I will advise you don't skip around this video. Now let's say, okay, before I start solving the problems, I would like to give you the standard integrals which will help us in this journey of integration. Now let's say you have a function of x. Let's say you have a function of x. Okay, and then the integral of that function of x with respect to x. Okay, so let's say you have a function such as ax raised to power n. The integral of ax raised to power n is that you will add 1 to the old power and then you will divide by that particular new power. You have an old power which is n, so but now in integration you need to add 1 to the old power to have a new power, so you need to divide all the function by the new power that you now have. Okay, so an example of something of that nature is that if I have something of this nature, 2x squared, the integral of 2x squared with respect to x means that I will just have 1 to be added to the 2, which is the power of x, and then I'll have 2 plus 1, which means that we have 2x cubed over cube, and anytime we integrate we add plus c to it. Okay, so why do we normally add plus c to it? Because there is an assumed constant. The constant can be 0, it can be 1 or 2, it can be any figure without x. Okay, so let's say you have 2x plus 3. You know, the integral of 2x plus 3, it is the same thing as the integral of 2x plus the integral of 3, all with respect to x. Okay, so if I integrate 2x, I'll have 2x squared over 2. Then if I integrate 3, I will have 3x, simply because ordinary 3 is like having 3x raised to power 0. So integrating this will be 3x raised to power 0 plus 1 over 0 plus 1, which, and 0 plus 1 of course is 1. Okay, so why do we normally have it as plus c? Let's say you have y, which is equal to 2x squared plus 7x minus 5. If you differentiate this dy dx, you should have 4x plus 7. Before you go too far in this video, I will advise you watch my video where I talked about differentiation. Now for me to integrate 4x plus 5, I should return to this particular function, because integration is anti-derivative, that is the reverse of differentiation. So if I integrate 4x plus 7, I should get this function. Okay, because it's like I'm integrating dy. This is y, so I differentiated it to have dy. So if I integrate dy, I should have y. Okay, so y is the antiderivative of dy. So if I integrate 4x, I should have 4x squared upon 2. And of course, if I integrate 7, I should have 7x, then plus c, because every time we integrate, we had a constant. So 4 divided by 2, that's 2x squared plus 7x plus c. So this is the reason why we always have it as plus c, because there is an assumed constant. So in this case, our c is minus 5. All right, by assumption. Now let's say I have another function, for instance sin x. Sin x, the integral of sin x is minus cos x. Okay, if let's say I have another function such as cos x, the integral of cos x is sin x. And of course, if I have another function such as tan x, the integral of tan x is minus ln cos x. Okay, so let me just have that in bracket. So let's talk about ln x itself. The integral of ln x is supposed to be, oh, that can only be done by parts, so I'll have it as x ln x minus x, but I'll talk about that very soon. Also, the integral of exponential x is exponential x, so we can also have functions such as sec square x. So the integral of sec square x is tan x, and the reason is because if I differentiate tan x, I will have sec square x. If I differentiate all these functions at the right hand side, I will have the left hand side. Okay, so don't forget plus c right here, plus c. Okay, so if I integrate other functions such as sec x tan x, if I integrate sec x tan x, I will have sec x, sec x. Okay, I know that for sure because if I differentiate sec x, I normally have sec x tan x. So let's just pause there and solve some problems. We will still have to add to the standard integrals as we continue in this video. So let's say we want to find the integral of exponential tan x upon 1 minus 1 minus sin x into 1 plus sin x. Okay, and the only variable here is x, so we should be done with respect to x. Okay, so for us to do this, I notice vividly that the denominator has to do with difference of two squares. That is, if I have 1 minus b and then I have 1 plus b, so I am already thinking of 1 squared minus b squared, because it is only the expansion of 1 squared minus b squared that will yield to this, or if we expand this, you should have this. So by simplification, I should have something of this nature: exponential tan x upon 1 minus sine squared x. That is, if you expand this bracket, then if you continue, you will know that by trigonometric substitution, one of the first trig identity is sine squared x plus cos squared x equal to 1. That's the first trig identity. Okay, and if you look at it very well, you will see that cos squared x will be equal to 1 minus, that is, if I take this sine squared x, if I transfer it to the other side of the equation, the sign behind the sine square x will change. It is actually plus right here, so when it crosses the equal to sign, it becomes minus. Then I'll have minus sine squared x, and that is why 1 minus sine square x is equal to cos square x. So 1 minus sine square x is equal to what? Cos square. So anytime I see 1 minus sine square x, I know what it means. I know that it means cos squared x. So I would like to substitute it right here, so that it becomes the integral of exponential tan x upon cos squared x, then dx. Okay, before I proceed, because some may not really understand how the expansion of this brought about this, let me quickly expand that. 1 minus sine x, open bracket, close it, then 1 plus sine x. If I expand this bracket, that will be 1 times 1, which is 1, then plus 1 times sine x, that's sine x. Negative sine x multiplied by 1, that's another negative sine x. And of course, negative sine x times minus sine x, that's negative sine squared x. So this will subtract this, so I'll be left with 1 minus sine squared x. So that's just it. And I know by the knowledge of trigonometry, and I've shown you right here, which is the same thing as this, so, and that's why we have it to be equal to cos squared x. So what do we do now? How do we find our way around it? Let me get rid of this space. One of the methods of solving problems on integration, one of the most important aspects of integration is what is referred to as substitution. Substitution is the most important aspect of integration, and that's what I'm going to do right now. Is a very important method in integration. And what we do in substitution is that you look at the question intently and you see which of the functions that we have can you substitute, and after you substitute that function, if you differentiate that function, differentiation is like breaking it down. So most times the function we substitute is always the one that is complex, so that when we break it down, we will see another function that we can use to divide that particular function. Now see what I'm trying to talk about. I know exponential tan x is complex than cos square x, so I'll say that u let u, that is by substitution, let u, I'm using u as the variable of substitution, let u be equal to tan x, because I know that if I differentiate u, that is do u dx, it will be equal to sec squared x. So I know that inside sec squared x there is cos squared x, so it will help me. Substitution is like breaking down, simplifying the integral, so that you will have a simple function to integrate. Okay, now that I have differentiated u dx, that means I have substituted tan x for u. And if I do that, and I am hoping that my cos squared x will be divided, so the only thing that will be left out that will still have x with itself is dx. So I need to find a way to eliminate that dx, and I will only be able to do that by making dx the subject of the formula. So that's the next thing. So anytime you say let u be something, you differentiate that u, and then you make the x the subject of the formula. Those three things are very paramount. So I make the x the subject. Okay, so for me to do that, I can decide to reciprocate both sides, so that I will have the x upon du to be equal to 1 over what? Cosec, I mean sec squared x. And I know that sec, okay, let me write it here. Sec is an inverse trigonometric ratio. Sec means 1 over cos x, and cot x means 1 over tan, and cosec means 1 over sine. If you don't know it, just check. If you are finding it difficult to know it, you just check the third letter C for cos, third letter T for tan, third letter S, not the last letter, third letter. Okay, so if sec means 1 over cos, okay, that means I am having 1 divided by 1 over cos squared x, because sec squared x means 1 over cos squared x, and of course that will be 1 times cos squared x, which is equal to what? Cos squared x. So it means that my dx du is equal to cos squared x. That means by simplification, I can really make dx the subject by saying dx is equal to du dot cos squared x. So I can go back, I can return to the integral now. Now the integral of exponential tan x, it will no longer be tan x again, it will now be u, because I had already substituted. Okay, then I am hoping that I will use something to cancel out cos squared x, so I need to write it that way. So I don't need to have dx again, I need to have the substituted version of dx, which is now du dot what? Dot cos squared x. So I am able to cancel out cos squared x, so the integral has now been simplified to exponential u du. And of course the integral of exponential x is always exponential x, so also the integral of exponential u will also be equal to what? Exponential u plus c. But remember that u is what? Is tan x. So finally I have exponential tan x plus c as the final answer. Now let's consider another problem. So let's say you want to find the integral of this, that is the integral of sec squared x exponential tan x plus exponential tan x over 1 minus. If you notice, you would see that we did this as the first example. Okay, so it will be very necessary for us to just solve this and then plus it with the answer we got for the first example, so that we'll have the final answer for this particular function. Now let's say we want to integrate this now, which is x sec squared x exponential tan x dx. So I just need to say let u become tan x, because if u is tan x, then du dx will be equal to what? Will be equal to sec x. Okay, sec squared x, the derivative of tan x. I said it the other time that you may need to watch my video where I talked about derivative. Okay, so I just need to make dx the subject of the formula now, isn't it? So now I should reciprocate. I don't need to change sec squared x to cos now, just like I did in the first example. I don't need to do that because I have sec right here. So sec right here, so it is perfect. But I just need to make the x the subject of the formula, and to do that I can reciprocate. Reciprocate means change the denominator to denominator, change the denominator to numerator, and change the numerator to denominator. Okay, so I can simply, now that I have reciprocated, I can cross multiply by saying dx is equal to du upon sec squared x. Okay, I hope that you understand what I did in that aspect. That means my integral will now become sec squared x exponential tan x will now become exponential u, and instead of having dx, I will now have du over sec squared x. So of course this will cancel out, so that eventually I'll have the integral of exponential u du, and if I integrate exponential u, I'll have exponential u plus c. So what is u? U is tan x, so tan x plus c, and that's the answer. We got the same answer for this particular. So finally that means the answer to this particular integral is exponential tan x plus exponential tan x, which is the same thing as 2 exponential tan x plus c. Okay, and that's it. Let's solve another problem. The marginal cost of manufacturing x yards of certain fabric is dk dx equal to 3 minus 0.01x plus 0.000006x squared in dollar per yard. Find the increase in cost k if the production level is raised from 2000 yards to 4000 yards. So the question is, what we were given is dk dx. Okay, dk dx. Okay, what they are trying to say is that k is a function of x. That's what it means to have x in the bracket. So if we were given dk dx and the question is saying find k, that is find cost, which means k. Okay, so it means they want us to integrate, because if we integrate dk dx, it will take us back to k. Okay, if you differentiate k, you will have dk dx, but if you integrate dk dx, you will have what? K. So they are reverse of each other. So what I just need to do is to integrate this dk dx so that I can have k, which is the cost. Okay, but the question is saying that the k, which is the cost that we need to find by integration, there is an increase in that particular cost, and it happens from 2,000 yards to 4,000 yards. So it means that the kind of integration they want is a definite integral. A definite integral is an integral with limits, with boundaries, that is from a to b. So I'll have the integral of dk, which is a function of x, dx, from 2000 to what, to 4,000 yards. Okay, and so let me just do that straight away. So from 2000 to 4,000. So what do I want to integrate? I want to integrate 3 minus 0.01x plus 0.00000. I think that's about 5 zeros, then 6x squared. So, and it has to be with respect to x. Okay, so the integral, if I integrate 3, I should have 3x minus 0.01. If I integrate 0.01x, I should have 0.01x squared upon 2, that is add 1 to the power and divide by the new power. So I will have 0.00000506, then x cube over cube. Okay, and that will be plus c. Okay, plus c, and it is happening from 2000, okay, to what, to 4,000. So anytime you integrate a definite integral, the first thing is you integrate first, then you put a boundary showing that it will range from 2000 to 4,000. So what I will do now is to insert what I have at the upper boundary, that is the one at the top here. I will insert it at every point where I have x. So that is really the implication of that particular boundaries. So I will have 4,000. Anywhere you can find x, equate it. So then I will have 4,000 as well over 2. Then I will have 0.5 zeros. Then I should have 4,000 raised to power 3 over 3. So this should be raised to power 2. After inserting 4,000 at every point where I can find my x, I need to subtract it from the time that I will now substitute 2,000 as well. That's what it means to integrate definite integral. When you have a definite integral, you integrate the function, then you put the upper boundary minus you put the lower boundary. That's just it. So let me just substitute the other one. That's 3 into 2000, okay, minus 0.01 x squared, which is 2000 squared, upon 2 plus 0.00000 into 2000, then raised to power 3. No, I should have 6 right here, upon 3. So I should have my bracket. You should press this directly on your calculator. If you press it directly on your calculator, you will have 58,000. Okay, 58,000, okay, in dollar. All right, so, and that's very, very correct. Or you can, if you use a scientific calculator, there is a part of your calculator that you can do definite integral. You will be able to see this button on your calculator, okay, dx. If you can find this on your calculator, you can simply use it to do this particular definite integral. So when you press it directly like this, you will have 58,000, and that will be very, very correct. Okay, but if you insist on solving this on your calculator, make sure you don't make mistake. Use the brackets correctly. You can do this first and then do this later on, and then subtract. So but your final answer should be 58,000. Let's solve another problem. A particle moves along the x-axis in such a way that at time t greater than or equal to 0, its velocity in feet per second is v of t equal to, okay, I have v of t which is equal to t raised to power minus 1, which simply means 1 over t plus t. How far does it move between time t equal to 1 and exponential 2? Okay, so I can have something of this nature. What they want to find, this the question says how far. How far means distance. So if I need to find my distance and I have my velocity, remember that velocity itself is the derivative of distance with respect to t. That means v of t is the same thing as ds dt, which is equal to 1 over t plus t. Now if I have ds dt but the question says I should find s, that means I need to integrate ds dt to find my s. Okay, remember that s by differentiation will yield ds dt, but if I integrate ds dt I will return to s, which is the distance. So s, which is distance, is the integral of ds. So I will have the integral of 1 over t plus t, but it has a limit. It's starting from 1 to what? Exponential 2. So if I integrate 1 over t, anytime you integrate 1 over x, you will have ln x. The reason is because if you differentiate ln x, you will have 1 over x. So if I integrate 1 over t with respect to t, I'll have ln t. Okay, ln t. If I integrate t, I will have t squared over 2, and my limit ranges from 1 to what? Exponential 2. So what do I need to do? I need to substitute the upper boundary so that I will have the ln of exponential 2 plus exponential 2 squared. Since I have t squared over 2, I substituted the boundaries wherever I had my t. So minus, I need to substitute 1 now, so I'll have ln 1 plus 1 squared over 2. Okay, so the ln of exponential 2 is 2. Okay, remember in mathematics, ln we always cancel out exponential, so that I will have 2. Okay, so plus exponential 2 squared means exponential 4, then I have it over 2, then minus the ln of 1 is like having the ln of exponential 0, because anything raised to power 0 is 1, and of course that's 0. If you also press ln 1 on your calculator, you will have 0. Okay, plus 1 over 2. So it's like having 2 minus exponential 4 over 2 minus 1 over 2. And of course 2 minus 1 over 2 is 3 over 2, then minus exponential 4 over 2. So eventually I'll have 3 minus exponential 4 over 2 as a final answer. Okay, also note that anytime you are dealing with definite integral, the constant normally cancels out. For instance, if I had plus c right here, this plus c, but this minus will affect the other c, so eventually it will be c minus c, which is 0. And that's why anytime we deal with definite integral, we don't normally put the c, because it eventually cancels out. Okay, now let's say I want to integrate another function. Oh, let's say I want to integrate exponential x plus exponential x dx. Now according to law of indices, I will be able to split this, because it becomes very difficult without splitting it. So if I can split this by law of indices, a raised to power m plus n means a raised to power m times a raised to power n. So it is by that law that I will do this. So I'll have exponential x times exponential x. Okay, so I can have my dx, because if they have the same base, you can add their powers. So that's it. Okay, so now that I have this, I can solve, and I will only be able to solve it by substitution. Okay, so let me say, since I have exponential all over the place, let's say u is equal to exponential x. And if u is exponential x, then I can say du dx will be equal to what? Exponential x. So I need to make dx the subject of the formula, okay, which is by reciprocating. And of course, if I make it at the subject of the formula, dx will be equal to du over what? Exponential x. So eventually I can go back to the question and rewrite it. Exponential x, don't forget that exponential x has already been substituted as u. Remember that exponential x, this particular exponential x, has been substituted as u, so I can replace it here as u. So eventually my question will now be exponential x, which is u, times exponential x, which is u, dot dx. What is dx? Dx is du over u. So u can actually cancel out u, so that eventually I will have the integral of exponential u du. Integral of exponential u is still exponential u plus c, but u is what? U is exponential x, then plus c. So that's the final answer. Let's say you have this as well, exponential ln x squared. Okay, it becomes very simple as well. So the integral of exponential ln x squared dx. Remember, exponential normally cancels out ln, which means the question is simply the integral of x squared dx, and that's, of course, that's x cubed over cube plus c finally. The next question says, given that d dx of x ln x is equal to 1 plus ln x, then find the integral of ln x. Now what this is trying to say is that the derivative of x ln x is given as 1 plus ln x. So now find the antiderivative or the integral of ln x. So what I would do using this particular equation, but because that will help me to be very fast about this solution, I will just make ln x the subject of the formula by taking this 1 to the other side of the equation. So it will mean that ln x will be equal to d dx of x ln x minus 1. That is, taking this positive 1, crossing the equal to sign, becomes negative. So if I integrate both sides, the integral of ln x is what I need from the question. It is equal to the integral of d dx of x ln x minus the integral of 1, and it is all with respect to x. The integral of derivative, it is that original function, which is x ln x, because integral means antiderivative. Okay, that is the reverse of derivative. So d dx of x ln x means the derivative of x ln x. So if I find the integral of the derivative of x ln x, I will have x ln x, which is the original function. Okay, so minus the integral of 1 is x. So this is the integral of ln x. Okay, so what I tried explaining about this particular aspect of the solution is that you may understand it this way, that integral will always cancel d dx. If that will help you, okay, then you should have x ln x. All right, so let's solve the last problem. Find the antiderivative of exponential sine theta cos theta plus sine root theta over theta. So I would like to do this one after the other. Let's say I have exponential sine theta cos theta first, d theta, that is with respect to theta. So I will say let u be equal to sine theta, so that the u d theta will be equal to cos theta. So if I make the theta subject of the formula, I should have du over what? Over cos theta. So that means the integral will now become exponential u cos theta. Then instead of the theta, I should have du over what? Over cos theta. So cos theta can cancel out, so that I will have integral of exponential u du, which is equal to exponential u plus c. And of course, u is equal to what? Is cos theta plus c. And that's the right answer for that aspect of the question. Now let's find the integral of sine root theta upon root theta. So I just need to say that let u be equal to root theta, or if I square both sides, u square will be equal to theta. So I can simply say that theta is equal to u squared. Okay, so the theta du will be equal to 2u, or if you don't like it this way, you can differentiate it as from this point. Okay, but I just want to make it easy. That's why I'm just being dynamic this way. So it will be very easy now. Then I can say that the theta is equal to 2u dot du. Okay, that means my integral will now become sine. Okay, I have already said that root theta should become u over u, then dot 2u du. So u can cancel out with u, so that I will have 2 integral of sine u du, which means 2 integral of sine u is minus cos u plus c, and of course minus 2 cos u is what? Root theta plus c. So which is actually very, very simple. So the only aspect you may want to ask question about is u equal to root theta, and of course that's by substitution. So if you can differentiate root theta, of course you will still have the same answer. If u is equal to root theta means theta raised to power half, and if you differentiate the u d theta, that will be equal to 1 over 2 theta raised to power half minus 1, which is minus half, which is the same thing as 1 over 2 root u, 2 root theta. And don't forget that root theta is the same thing as u, that's 1 over root theta is the same thing as u, that's 1 over u. So you have just gotten the u d theta to be equal to 1 over 2u. And of course, if you make the theta subject of the formula, the theta, by first of all reciprocating, will be equal to 2u, so that the theta is equal to 2u dot du. So that's just it. So share these videos with your friends, like and subscribe. Bye for now.